amount of net work done on an object is calculated using all of the force, so the net force. So that can be stated as work net equals F net times the distance. Work equals a scalar quantity because it has no direction.
Go.
When energy is added to a system, so plus energy to the system has positive work done, so positive work. When energy is taken away from a system, then that means that negative work is done. So work is being taken away. If no energy is added into the system, the net work stays at 0 or the same. Force, there's only work if the force exerted is horizontal to the motion. If force is perpendicular to the motion, no work is getting done. Only work is getting done when there's force that is perpendicular to the motion. So that equals a change in work, or it just equals work.
Go.
If force is exerted at some other angle to the motion, only the component in the direction of the motion does the work. So that means if it's forced at an angle, force is at an angle to the motion, that means that only a portion of the force is doing the work. So it can be expressed as work equals force times the cosine of the angle, which is right here, cosine of the angle times the distance moved. Now that we've given you a basis of energy and a basis of work, and completed work for the most part, we're going to go back to energy. Going back to energy. Energy, as we stated, is the way we use it in physics in our class is mechanical energy. And mechanical energy, ME, can be broken down into two forms. That equals kinetic energy, which can be expressed as 1/2 times the mass times the velocity squared. Or it can be broken down into potential energy, which is mass times gravity times height. These are the two forms of the mechanical energy. The SI of kinetic energy equals joules, the same as work and energy. Now, kinetic energy is when an object is in motion. So if the ball is rolling this way, it has kinetic energy. It does not have potential energy. Only at 1 point does it have full amount of potential energy. Is at the beginning when it's not moving, but it has stored energy for down a slope, and in the middle it should have half of its potential energy and half of its kinetic energy. At the bottom, it'll have full kinetic energy, no more potential energy. We can find work with kinetic energy. It's called the work energy theorem. We can find work based off the change of kinetic energy. So kinetic energy final minus kinetic energy initial. Potential energy, as we stated before, equals the stored energy available to do something when it is needed. But there are many different types of potential energy. There's chemical potential, elastic potential, like something compressed in a spring, but the one that we focused on in our physics class is gravitational potential energy. As we stated before, the potential energy equals the mass times gravity times the height of an object. Gravitational energy is the energy stored to an object due to the relative position above a chosen point. Any height, called the reference level, can be used. Potential energy is based on the mass of an object and the object's height above the reference level, and the acceleration due to gravity at the object's location. Since work is the transfer of energy, when an object is lifted upward, the gain in potential energy equals the work done against gravity. So work equals a change in potential energy which equals mass times gravity times the change in height. We've talked about energy, and we've talked about work, and we've talked about how energy and work combine. Now to move on toward power. Power is the rate of doing work. The work done on an object divided by the time it takes to do the work. Power is expressed in P, which equals work divided by time, which also can be expressed in force times distance divided by time, which also equals velocity divided by time. The SI unit of power is a watt, so uppercase W. Power is a scalar quantity. Power is often measured in kilowatts. A kilowatt equals 1,000 watts.